Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Hafidah binti Muhammad Nasir. Matrix number CF190050. I want to present about our company background, which is a Geoscience Engineering Sdn Bhd specialized in geotechnical and civil engineering with 22 years of experience. We focus on geotechnical contracts but expanded our reach to foundation works, ground improvements, coastal protections, and instrumentations. The company also operates in specialties such as rock slope and soil slope rehabilitation of retaining structures and foundation works. Scope of work foundation. Scope of works foundation work, general civil and building, soil investigation, groundwater drainage works, rock, and soil slope rehabilitation of retaining structure, ground anchor. Our vision is to be the one top specialist in geotechnical engineering in the global. And our mission to train and raise standard of competency in our workforce. We will not compromise on the quality of our work to ensure the client's needs and interests are addressed at all the time to keep safe the environment, people, and under our control. Okay, next is our organization chart. Our project director is Nur Sabrina binti Daud. Our project manager Nur Aimanana binti Rahman. Site supervisor Ain Amira binti Omar. And design engineer Nur Hafidah binti Muhammad Nasir. Okay, the title of our project is the development of Marunda Center at Jitra Kedah. About our project is the Government of Malaysia via Jabatan Kerja Raya has opened the tender for a design and build contract. JKR has carried out number of subsoil condition surveys, including exploratory boring, undisturbed sampling and laboratory tests in their commercial area for the development of Marunda Center. The developer shared the soil data as obtained with the JKR study team. The survey indicates that the very soft layer and value equal to 0 to 3 as deposited in alluvium covers the top of the surface and medium stiff clayey silt likely Pleistocene sediment and value equal to 5 to 12 is laid below the alluvium sediment. Stiff to hard clayey silt appeared under the Pleistocene sediment at existing BH7. The end value of this hard silt shows 14 to 16 or over. Okay, next is analysis of soil investigating. The standard first is standard penetration test. The standard penetration test was carried out according to BS 137749 1919 method 3.3 using an open-ended longitudinal split spoon sampler, a cutting shoe at the lower end and a coupling at the upper connect the sampler to the AW road. Next is undisturbed and disturbed soils. Representative samples of disturbed and undisturbed soil were taken during the investigation and sent to the laboratory for visual inspection and testing. Additionally, the split spoon sampler was used to collect soil samples for disturbed areas. And next is direct shear test. The consolidated drain strength characteristics of a sample are measured using the direct shear test. When a single shear plane is applied to a normal load and constant strain rate, the load response is recorded. The common shear strength characteristics can be found by performing this test under different normal loads. And last is attachment limit test. The plasticity index indicates, among other things, the decrease in moisture content required to change a soil from a liquid to a semi-solid form. It provides the range of soil moisture at which a soil is in a plastic state. The soil cohesiveness possessed by a soil can be measured using the plasticity index. Thank you.
Hi, Assalamualaikum. My name is Ain Amira. I want to continue our group presentation. For the grouping of the load, the axial load from column consists of 5 columns, C1 200 kN, C2 500 kilonewton, C3 750 kilonewton, C4 1000 kilonewton, and C5 3000 kilonewton. And we also separate the group into three groups. For group A, for column C1 and C2, for group B, C3 and C4, and the last for group C, C5. This is the analysis of soil profile for BH01 consists of depth, soil type, and value, characteristic, acidity, degree, and the delta. And this is the analysis of soil profile for BH02. This is the for BH03. And this is the analysis of soil profile for BH04. And the last one is for BH05. Next, we continue for the soil profile at Borholog. Okay, this is the soil profile for BH1 and BH02. This one is the soil profile at BH03 and BH04. Last, the soil profile at BH05. And for the foundation drawing, we split into three groups. This is group A, group B, and group C.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aimalena binti Draman, matrix number CF190080. And now I will continue with the foundation analysis. A deeper, more capable soil layer is where the loads are distributed by this form of foundation. Piles are utilized to transfer the load to the underlying bedrock or a stronger soil layer when one or more topsoil layers are very compressible and unable to support the load transmitted by the superstructure. Piles are used to gradually transfer the structural load to the soil when bedrock cannot be found at a reasonable depth below the surface of the ground. The frictional resistance created at the soil-pile interface is the principal source of the resistance to the input structural load. This is the equation for the Meyerhof method to estimate the load carrying capacity of the pile point QP. Then, this is the table we will refer by using effective soil fraction angle of the bearing stratum. For the pile design, deep pile that has three groups, which is group A, group B, and group C, with the same type of the pile, that is pre-stressed concrete pile. Then, this is a summary of pile design. We can see here the ultimate load carry capacity QU for group A is 705.72 kN, for group B is 1525 kN, and for group C is 5504 kN. Once the calculation of the ultimate point QP of the deep foundation for the Meyerhof method is performed, the end value from the calculation of the method show a fairly significant difference. This is mainly due to the angle of friction value of the supporting soil be very high and causing the soil friction and Q and size of the pipe for Meyerhof method to be at a great difference.
Settlement analysis. Soil consolidate when loads from buildings are applied to them. As the soil around and beneath the foundation adjusts to the loading, all foundations settle. This is the formula that will be used to checking the settlement. For the group A, the settlement total are 17.6 mm. For the group B, 53.4 mm. For the group C, 256.3 mm. From the manual calculations, the critical load for the column is at 3000 kN. Moreover, column transmits the load from roof slab and beam, including its own weight, to the foundation. The foundation, which is pile foundation, are used for the structure due to its sufficient and ability to support the proposed structure. There is also a hard soil layer available at the depth under the structure, with the value of 43 degrees showing the soil strength is able to bear the load from the structure. The calculation of Meyerhof method for the QP load carrying capacity of the pipeline have been carried out. The n values for the Mayow-Hermatek calculation show that a fairly significant differences. This is largely due to the angle of friction value between the resultant of frictional force and the normal reaction makes it with a normal force of the supporting soil extremely high and causes the bearing capacity to have great differences. From the Mayow method, the value of Q is 500 to 3000 kilonewton that was used in the design of a better safe factor of 3. The settlement check for the Group A and Group B passed the design requirement. However, the settlement check for Group C have to redesign. The type of pile it doesn't pass the requirement. The group of pile need to design for the load of 1000 kilonewton above at one column each.